Fluid coding and AI. A generic coding agent can write a clean SQL rewrite and still be dangerously wrong. For data engineering, the scary failure is not red text in a terminal. It is a dashboard that runs, looks polished, and quietly changes the business meaning. So the real question is not whether Cortex Code writes nicer code. It is whether a data-native agent can make fewer plausible but wrong changes because it understands Snowflake context. Here is the test I would actually trust. Not one prompt, not a pretty diff. 6 data engineering jobs: optimize a slow query, debug a semantic model, generate a Streamlit dashboard, create a dbt-style transformation, handle governed access, and extend the agent with project-specific tools. The winner is not the agent that produces the most code. The winner is the one that checks the warehouse facts before changing the system. Start with the fair baseline. Generic coding agents are strong now. Codex, Claude Code, and GitHub Copilot's Cloud Agent can read repositories, edit files, run commands, create pull requests, use instructions, connect tools, and iterate in background environments. So if the task is a normal software engineering loop, the generic agent is credible. It can refactor Python, it can update tests, it can trace a codebase. The problem is that data engineering correctness often lives outside the repo. A repository can tell an agent what the code says. A warehouse can tell it what the data means. That difference matters. Revenue may be a semantic metric, not a column. North America may be a governed region filter. Forecast accuracy may mean absolute error, not a percentage difference. A query can return rows and still compare the wrong dates. This is where plausible wrongness gets expensive. The output compiles, the chart loads, and the business definition silently drifts. Cortex Code is Snowflake's coding agent built into the Snowflake environment. In Snowsight, it can use the current SQL file or notebook as context, generate or explain SQL in Python, and answer account questions about cost, query performance, governance, and permissions. In the CLI, it can connect to a Snowflake account, execute SQL, view tables, validate Cortex Analyst semantic models, read and write local repositories, run shell and git commands, and work on dbt projects or Streamlit apps. That does not make it magic, it makes the loop narrower and more data-aware. Take SQL optimization. A generic agent might read a slow query and suggest obvious edits, simplify common table expressions, remove joins, add an index, or resize the warehouse. Some of that advice may be irrelevant in Snowflake, and some of it may be theater. Cortex Code's advantage is the ability to ask Snowflake-specific questions. What does query history show? Was there spilling? Did partition pruning fail? Is clustering relevant? Is search optimization or query acceleration a candidate? For this round, no query rewrite should count until it uses execution evidence. The strongest public evidence is around Semantic SQL, not Cortex Code as a full coding agent. Snowflake reports that Cortex Analyst reached above 90% SQL accuracy on an internal 150-question business intelligence benchmark. On the same evaluation, Snowflake says a single-shot GPT-4o baseline reached 51%. The examples are exactly the kind of mistakes data teams fear: wrong dates, missing date comparisons, rolling window errors, and a forecast accuracy metric interpreted differently from the semantic model. This supports the core idea, schema, but this is the caveat that keeps the comparison honest. That benchmark is for Cortex Analyst and Text to SQL. It is not a public end-to-end benchmark showing Cortex Code beating Codex, Claude Code, Copilot, Cursor, or Devon on dbt changes, Streamlit apps, governance fixes, and SQL optimization pull requests. The benchmark case is strong for the Semantic SQL engine underneath the story. The full Cortex Code claim still needs a hands-on bake-off. Now look at Streamlit dashboards. A generic agent can build a polished app quickly. That is not the hard part. The hard part is whether the app uses the right Snowflake runtime assumptions, queries columns the current role can actually access, and avoids dummy credentials or local-only behavior. Cortex Code documentation includes workflows for building Streamlit dashboards on Snowflake data and returning deployed links. Its bundled skills include Streamlit and Snowflake app creation, debugging, filters, Snowpark queries, Altair charts, and theming. The dashboard should be scored on live compatibility, not screenshots. For dbt-style transformations, the same rule applies. A generic agent can infer model files, write SQL, and create a neat folder structure. But if it invents table names, misses role privileges, ignores task scheduling, or breaks a downstream MART, the repo diff is not enough. Cortex Code CLI docs call out local repository access for dbt projects, and the bundled skills distinguish Snowflake dbt workflows from standard dbt workflows. They include deploy, execute, schedule, documentation, and lineage. In this round, the agent has to prove the transformation against real warehouse objects and downstream impact. Governance is where a generic answer can be actively dangerous. If a query fails, the easy bad fix is to broaden a grant or tell the user to run as an administrator. But real Snowflake environments have role hierarchies, masking policies, row access policies, PII tags, and account-level audit trails. Cortex Code examples include checking table access, finding PII tag tables, and diagnosing permission errors. Its security guidance recommends least privilege roles and says not to use account admin for routine work. The right agent should explain access, not bulldoze it. Extensibility is not a one-sided win. Generic agents have broad reach. They can work across app code, infrastructure, GitHub workflows, issue trackers, local tools, and custom MCP servers. If your data stack spans Snowflake, Databricks, BigQuery, Airflow, Terraform, and product services, that breadth matters. Cortex Code is trying to combine that agent loop with Snowflake, native skills, subagents, hooks, MESIP, ACP editor integrations, and an agent SDK. So the question is not open versus closed. It is broad context versus native context. Cortex Code also needs operational discipline. The CLI can run shell commands, read and write files, use the web, and execute SQL. Snowflake's security docs describe confirm actions, plan mode, and bypass mode. They also recommend browser authentication by default, short-lived personal access tokens when needed, private sessions for sensitive work, and least privilege. That matters because warehouse, native power cuts both ways. A better context window does not remove the need for review, scoped roles, regression questions, and cautious production changes. Here is the practical verdict. If your task is mostly repository engineering, a strong generic coding agent is still the right baseline. It is flexible, fast, and good at ordinary software loops. If the task depends on Snowflake semantics, permissions, query behavior, lineage, and governed data access, Cortex Code deserves a serious test. Its advantage is not mystical model quality. It is that the warehouse can become part of the agent's test harness. For data engineering, context beats a confident diff. If this helped you separate real data engineering verification from agent hype, like the video and subscribe to Fluid Coding and AI. The next time an agent gives you a beautiful SQL diff, ask one more question. What warehouse evidence proved it was right?